Sir, I'm already.
Hi, everyone. Welcome to be here with us. Welcome to this webinar on applied artificial intelligence, evolution of real-time projects. As we enter the age of artificial intelligence, we are faced with both opportunities and challenges. Artificial intelligence has the potential to help us address some of the most pressing issues of our time. In this session, in this webinar, we will explore the transformative impact of artificial intelligence on society and the economy. We will also examine the challenges and opportunities presented by artificial intelligence, from legal and regulatory implication to the potential for improved efficiency and response times. As we consider the impact of artificial intelligence in society, we must also think about how to ensure that everyone benefits from this emerging technology. We hope that this webinar will shed light on the complex issues surrounding artificial intelligence and inspire new ideas for addressing contemporary societal challenges through also open innovation and inter-firm collaboration. So I'm Fabiana Sepe, and I'm the moderator of this webinar. I'm a research fellow at the Department of Economics Management Institution at the University of Naples Federico II. And my research field is about management and also artificial intelligence applied in management and business context. Starting from now, we have 5 different teams that will show us their works. Each team has 30 minutes to present and discuss their project. So we can start now with the first team. The topic is wireless display data extraction using artificial intelligence techniques. The guiding experts are Dr. Priya, Mrs. Nusrat Ansari, Professor Dr. Shashi Dugad. While the students taking part in this project are Nair Ravindran, Manigandan Kashimani, N Guru Akaash, Varun Tripathy. So please, starting from now, you can present your project. Please share also your screen if you wish. Thank you.
Yes.
Okay, ma'am.
Thank you for this opportunity. I just like to introduce my team. Myself, Priya, along with my team's members. That is, my students are there with us here. So we work this particular project along with TA. Sorry. So so now my students will be presenting the same. Yes, Ajay, you can share the screen and you can start with your presentation. Best of luck.
Thank you, ma'am. So I'm Ajay Nair, and our project's topic is wireless display data extraction using AI techniques. So we have made this project in collaboration with TIFR. So these are the contents of our presentation. So the advent of Internet of Things, IoT, has seen fundamental changes in the way we do data acquisition, storage, and analysis. IoT in conjunction with AI has the potential to transform society and improve human life. Industrial and research data sets are notoriously difficult to extract in a real-time streaming fashion. Several security issues also exist, especially some complex and specialized controllers. While extracting data from them, it becomes quite complicated. So our project aims for the extraction of display panel data using a non-invasive and wireless approach with the help of AI techniques. So I'll go through our problem definition now. IoT and AI have the power to change IoT civilization and enhance human existence. Industries and factories generate enormous amounts of data, and if we can manage that data, we can accomplish amazing things. However, it is far easier said than done because real-time streaming data extraction from industrial and research datasets is notoriously challenging. So direct physical access to these specialized controllers for data collection may be restricted due to security considerations as well. With the help of several OCR techniques, our project seeks to wirelessly and securely extract data from the device and save it in the cloud or standalone server to perform further computations.
Okay, so moving on to the block diagram.
Sorry, Gator, can you switch off your microphone, please? Gator, please, can you switch off your microphone?
Geeta. No, I'll mute them, please. Yeah, mute.
Thank you.
Okay, so moving on to the block diagram. This system can take two parts of inputs, that is a real-time data and a pre-recorded video data set. The input data from the IP webcam is passed to the video to the frames conversion code. Once the raw data is acquired, the pre-processing techniques are applied to enhance the accuracy, followed by the training of YOLO V5 model and is performed on a curated custom dataset. After the completion of the training phase, the model is evaluated on several parameters to check the accuracy of the model. Then later the model is then passed to the post-processing phase, and the final output is displayed on a desktop application, which is stored in a CSV file that is for further reference and future analysis. Move on to the next slide. So I will be explaining the modular diagram. So modular diagram has various phases over here. First is data gathering phase. As I explained, there's an input phase that is proposed by the module, and the system input can be either a real-time video data or a captured video data. The real-time video data then can be captured video stream either by IP webcam or a ESP32 webcam model. Then the data from various display panels and are converted into individual frames and are used to create the data set. Then moving on to the pre-processing phase, there are four to five phases, which is image padding, image enhancement, image annotations, and data split. Where the image padding is the first pre-processing phase, that is the proper creation of 960 to 960 pixel images by adding proper padding. And then that is the image enhancement phase, which is used like image sharpening technique is used over there. And then image annotation phase, where we are annotating the digits from 0 to 9. And then there is a data split phase where it is divided into three parts. One is annotation, validation test phase, and validating test phase. Then moving on to the training phase. Training phase is like it is trained on a curated custom dataset. Your YOLO parameter tweaking is done, and it is composed of three models. That is CSP Darknet 53 as the backbone, SPP and PANet in the model neck and head. Then moving on to the interface phase, where it is where there's a creation of bounding boxes are created by the image in the images by the model for each custom dataset, and a separate bounding box is created around the object. Then that is post-processing phase, where digit detection, recognition, and merging algorithm is used. Finally, there is a user interface where the video data and real-time data is shown. Okay, moving on to the next slide.
So talking about the image enhancement technique we have used the image sharpening technique to enhance the image. So in sharpening the images, we are enhancing the edges of the images. So a 7 digit number is nothing but collection of edges. So by enhancing the edges, we are thereby increasing the quality of image. As you can see on the right side of the image, the numbers are clearly visible compared to that of the left side, which is the original image. So we are applying this enhancement on each and every frame of the video before sending it to for the processing of the image. Moving on to the next slide.
So first we created a general model which would work on any type of display screen. So we actually tested many OCR engines out there on the internet. So we found these two, EC OCR and Keras OCR, to be the best, and these are their results. So for making the general OCR model, the methodology that we have used, I would like to explain it here. Stable recording from display units with various font sizes and styles were used as the source of information. To capture that stable video, an IP webcam application in mobile or ESP32 cam module can also be used. Then the Keras OCR model is used for text detection on the image frames, which is based on the craft detection approach. The user can also create their own ROIs in case the detection engine cannot detect particular areas. And then finally, an ROI template will be created from both these methods. And cropped images are then created from the video frames using the ROI template. The next phase, EasyOCR model, is used for text recognition, generating results that are stored in an array finally, which can then be displayed in a CSV format in our interface.
So as Ajay was saying, the region of interest are captured by the Keras engine. So basically all the regions will be automatically detected, and in case some regions are missing, we can manually create that region and send it to the processing. Once the processing starts, it will record the data on real-time basis with the timestamps. Moving on to the next slide. So this is where so this is the evaluation metrics we have used for both the models. For Keras OCR model, we have used the TED eval matrix, and for Easy OCR model, we have used the character error rate, which is nothing but the calculation of addition, insertion, and removal of character from the text. So, it is basically an OCR metric to calculate the efficiency of the model. So it came around 23.30. A good model ranges from 15 to 25 of a CER as per the standard. So it's between the a good model. Moving on to the next slide.
So moving on to the real-time digit detection and recognition using YOLO model. This is the part of the TIFR project. Moving on to the next slide. So the best part of this model is it is not dependent on the distance between the camera and the screen of the machine, and it is also not dependent on the resolution of the image which we get from the camera. This YOLO model is a neural network model which provides real-time object detection. So in this, we have detected 10 digits, 0 to 9. And apart from that, this YOLO model is a popular, finest and light model. So it is not dependent on any fluctuations and other objects in the image. So this YOLO model is fast, robust, and it is used for OCR purposes when compared to other OCR models. Moving on to the next slide. The methodology employed in this model is initially an image file .jpg and a separate .txt file is created for each of the image. Then the coordinates of the bounding boxes for each characters are written in the text file. The YOLO format is displayed as here, that is the class of the object, the X coordinate and Y coordinate of the bounding box, the width and height of the bounding box. All these values are normalized from 0 to 1 range. Moving on to the next slide. So these frames are got from the video dataset, which Varun explained in the modular diagram, and it is converted into 960 x 960 pixels to get a clear standard image. Once these annotations are done, the image and the annotations are then given to the YOLO model. The video which we took was of 3,591 frames, and these images were divided into training, validation, and testing purposes. These are the several classes which are represented here. Moving on to the next slide. So YOLO model version we have used is 5 and epochs are 100. These epochs, after every epoch, the accuracy of the model gets increased and better. So the YOLO model is trained on custom data set, which is manually done by all four of us. That is, we have created annotations for each of the object numbers in the image. These are some specific configurations, that is intersection over union, multi-label, confidence, and maximum data scores. The YOLO model training took around 16 to 18 hours to complete the model. Moving to the next slide. This is the performance metrics confusion matrix. As you can see that most of the digits have greater accuracy of 0.99 to 0.95. So the overall accuracy is 0.96, that is 96.7%. Moving on to the next slide. This YOLO model, it is the number of instances of each of the digits which are present in our data set. Moving to the next slide. These are some of the performance metrics like box loss, object loss, classification loss, precision, recall, box loss, and other mean absolute precision loss, and every other performance metrics of the YOLO model. Right. In this graph, you can see the F1 score and the precision confidence score. As you can see, it is increased from after certain epochs. And in the below image, you can see the precision recall curve and recall confidence curve. Moving on to the next slide. So this is the merging algorithm which we have implemented. It is independent of the distance between the digits. So since we have taken the relative distance between each of the digits, so we are grouping the digits based on the relative distance between each of the digits present on the display panel. This is the sample unit of the display panel. It has 18 digits which are grouped 3, 6, 3, 6. So we have to split it into groups and merge it based on the distance between them. Moving on to the next slide. So these are some results. As you can see on the right hand side, a CSV file is generated which contains 4 different numbers. The first is the 3-digit number of the display panel. After that, the 6-digit number, and finally the other 3 and 6-digit number. These are done dependent on the distance between the digits. On the left hand side, you can see the IP webcam setup, which is used for YOLO model implementation. Moving on to the next slide. These are some results of our web application. We have created a web application which automatically displays the results on a real-time basis along with the timestamp of the frame of the video. On the left-hand side, you can see the ESP32 camera module, which we have used for capturing the photo frames from the display unit. Moving on to the next slide.
Okay, so moving on to the methodology of creating the ESP32 cam setup. So first we have to create a LAN network by assigning a static IP addresses to the ESP32 cam module, and then plug in the camera module to the ESP32 cam MB USB programmer and connect it to the laptop with a USB data cable. Then after that, selecting a appropriate ESP32 board and a COM port and uploading the code of ESP32 module using the Arduino IDE. There are 2 options for streaming, that is, one is web server and one is RTSP server. So ESP32 model starts with a web server and on the connection by a web browser that sends the images from the camera to the web browser, and so it is more like a stream of images. And to run that RTSP, besides with a server, a streamer and a session to handle the RTP communication is required. The Wi-Fi client is to handle for the connected RTSP client. After flashing a serial monitor and copy the desired streaming links to the applications. Move on to the next slide.
So next we would like to show a demonstration video of our project. So Mani will present the screen now.
Thank you. Thank you for your presentation. I would ask.
Ma'am, actually, we have a demonstration video now. So.
Okay. Perfect.
So, 5 more minutes, ma'am.
Okay.
Is it visible, the presentation video? Actually, my
Yes.
has some problems, so I will be sharing the video. Let me know if audio is visible, audible.
No,
Audio is
it's
not audible. Only whatever you speak is audible.
Okay, Mani will continue with the audio then. Mani, please speak. Guru will present the video.
So this is the main UI. So you have to log in to the application by inserting your details. This is the home screen of the application. There are two options: connect IP cam and Guru, pause the video. Connect IP cam and upload video. So connecting the IP camera will connect the RTSP module, camera module to the application, and uploading video camera is basically using a local copy of the video and applying the YOLO model on that local video. Guru, go ahead. So here we are using the RTSP module through an application, IP webcam application, and this is the ESP32 camera module. So this is the camera setup, and here we have to enter the IP address of the RTSP camera module. Once we have entered, it will take some time after submitting the RTSP link to show up the video. Few seconds. As you can see, we are connecting. We are capable of connecting more than one RTSP stream at a time.
So in this way, we can connect multiple cameras as well. So it is scalable product.
As you can see, there are two cameras showing the results on the application side by side. Once we have connected enough cameras, we can start the detection, or we can connect more by clicking on the connect more option. Once we have clicked the start detection button, the detected result will be shown on the CSV files. As you can see, these are getting updated and on real time on both the cameras.
Good work.
So that's basically it.
So that was our presentation.
Okay.
So lastly, I would like to conclude. Varun, please.
So concluding our presentation, we can say that YOLO model pre-processing of the data was done and implemented before training the model. Custom data set based on YOLO training model was implemented. digit detection and digit recognition was implemented properly, and then merging of the digits, merging algorithm was used. IP webcam integration with custom trained YOLO model was implemented, and then real-time YOLO model for digit detection and digit recognition was done. Video streaming using cost-effective camera, that is ESP32 camera model, was used. Even multiple streams can be handled, as it was shown in the video earlier, and even multiple users can now log in into their account to view real-time detections, and timestamps has also been added for predicting the videos and allowing for more accurate tracking, and real-time updates have been implemented for CSV file. So yeah, let's move into the next slide. Okay, so these are some references that we have used for generating. Okay, thank you.
Thank you.
Thank you. Thank you very much to our speaker, Varun Tripathy. And thank you very much also to the other members of the team, because, you know, the project is very, very impressive. I will ask to the other participants if they have some questions, suggestions. And I also advise all participants to post their questions in the chat box, so it would be, you know, easy to read out. Thank you.
Hello, hi. I just one question, if I may. Thank you for sharing on the project. So, because since you are using YOLO, may I know what type of neural network YOLO model that have been used in this study?
What neural network are you using in the study?
Yes.
So basically, this YOLO V5 model uses the darknet model of the neural network. So we have to configure it based on the number of objects in the model, and along with it, we have to give the epochs and all the number of iterations which we have to do. So currently in our project, we have taken 100 iterations, which took around almost 18 to 20 hours for the training purpose. And this training, we have to provide the data set in the terms of image and text file. So manually, we have to create the annotations around the objects which we have to find. That is the 0 to 9 digits. So each number will have a separate class digit. So 0 will have class 0 similarly, and so on and so on and so forth. So after that, the YOLO model gets to know that what object is called as what. So it will assign the names to that objects in the image. When we get that, when we feed that details into the YOLO model will provide us with its accuracy and efficiency, which then can be used for our testing purposes. The testing file also provides us the bounding boxes, detected bounding boxes by the YOLO model.
No. See, bounding boxes are not, object and detection classification you're doing. Dr. Nooraini is asking what CNN, whether it is a CNN or what kind of a RNN or what kind of a neural network.
Yes.
You're using a ANN. We know it's an artificial neural network, but in which neural network are you getting these?
It comes in CNN, convolutional neural network.
CNN.
Right.
CNN
Right.
wouldn't go for. Okay, no issues. I have one question to you guys. How many users have you really tested with?
So as I mentioned, this is a project with TIFR. So the Professor Shashi Dugad sir from Tata Institute, he guided us, and we also deployed our project there. So currently we have our user as TIFR itself.
Okay, one user then. Huh?
Yes. The TIFR who works with different industries to collaborate on these projects.
No issues. Thank you. Good effort.
Sir, actually, it is just the prototype now we have developed. Now it will be further extended based on the certain value terms will be generated. So again, next one more year will be continuing with this project. with add-on features.
Okay. Good effort. Good work. Thank you.
Thank you, team.
Thank you.
Thank you.
Over to you, Dr. Fabian.
Okay, so thank you everyone. Now we are gonna to leave the floor to the second team. The topic of the project is fish disease classification. The guiding experts are Associate Professor Dr. Nooraini Yusoff, Associate Professor Dr. Hazlyna Harun, and Associate Professor Dr. Mohamad Ghozali Hassan. Students are Mrs. Amiera Syazlin, MD Azhar. Okay. Thank you. Please share your screen if you wish. Thank you.
Yes, thank you. I can introduce a bit on this project, yeah. Good evening, everyone. It's almost 7 from Malaysia. Okay. Thank you for having us. So this project is about fish disease classification. Particularly the name of the disease is white spot fish disease. So this is one of our projects that have been funded by the Ministry of Higher Education Malaysia. And for doing this project, we work closely with NAFISH, the National Fish Research Institute in Malaysia. And our future aim is to have like an early fish disease detection system. Okay, so this is as a fundamental step for us to, in order for us to have some model to do the disease classification, and later our immediate future is to have a early fish disease detection system. So I have Miss Amiera that will be sharing with us today. So yes, Amiera, please.
Okay, thank you, Rata. Good day, everyone. I hope everyone is having a wonderful day. I am Amiera Syazlin, and my guiding expert, Dr. Nooraini, Dr. Hazlyna, and Dr. Ghozali. So let's start my presentation. So aquaculture sector in Malaysia has experienced rapid growth over the past decades, since it is important for both food and livelihoods. As fish is an excellent protein source that is easily digested by the human body, the demand for it keeps rising along with the increasing global population. The technological revolution has turned this business into one of the fastest growing food industries, and Malaysia has become one of the world's top 15 aquaculture producers. So considerable effort should be expended on aquaculture fish management and production to ensure the sustainability of fish production to meet this country's 30.75 million population demand. However, one of the challenges that could slow the growth of the sector is fish disease outbreaks. Especially after mariculture is introduced in Malaysia, protozoan white spot disease has been a problematic infection in the mariculture system. The idea of mariculture is brilliant, which actually it is a conventional way to create large amount of fish more quick and efficient. Unfortunately, the overcrowded and stressful condition of this system make all the underwater life more prone to disease. So the disease became the primary focus of the research. The disease became the primary focus of the research as the disease showed a rapid increase in mortality over several days. So more and more researchers have explored the use of AI in fish disease detection, as it could be the key to early prevention of fish disease outbreak. Therefore, in this research, since protozoan white spot disease is extremely dangerous and could cause significant economic losses to the country, and as that we are in the 4th industrial revolution, this study proposed the strategies of using image processing on underwater images to ease the classification process to detect white spot disease in the early stage. The integration approach could successfully use AI for disease detection while ease the participation of fish experts in protecting the aquaculture provision. So this study demonstrates a new procedure for white spot disease classification using underwater image, concerning on the development of integration between contrast-limited adaptive histogram localization, CLAHI, and convolutional neural network, CNN. So the first part of the process started by collecting the data set from the experiment conducted in NAFISH, Fish Research Institute facility in Penang, Malaysia. The underwater images were extracted from the videos obtained in a month. Then the procedure begins with image processing to enhance the image degradation to be an input for the next classification process. This study used an image enhancement technique, namely contrast-limited adaptive histogram equalization, CLAHI, to improve contrast and highlight the image important features. After undergo the enhancement process, Enhanced images were processed using CNN to detect the presence of white spot disease. We believe the ability of CNN to learn and extract the disease-important features on large datasets as its convolutional layers could scan over the underwater images, where finally the last layer would classify the image. As the result, a total of 30 normal fish images and 30 protozoan white spot infected fish images were tested. Tables shown demonstrate the accuracy of all the tested images. The values shown in the diagonal pattern accurately detected normal and infected fish images. 29 infected fish images were correctly detected, while a single image was wrongly detected as normal, while one normal fish was incorrectly detected as infected, and the rest 29 were correctly detected as normal. According to the equation, 96.67% of accuracy has been achieved for protozoan white spot fish disease classification. So as an alternative to the traditional method, the demand of fish disease detection using new approach should be fulfilled to continuously sustain the productivity of aquaculture sector. And one of the efforts, this study strategy of using image enhancement technique on the degraded underwater images, successfully making the classification process more accurate in detecting the contagious protozoan white spot disease. Combination of CLAHI and advances technology of CNN has showed the potential to detect the disease in the underwater environment. So we believe 96.67% accuracy achieved demonstrates that this method could be the critical key to prevent the disease extremely dangerous outbreak, as early step of cure could be made when the fish body started to show the early sign of infection. So besides this result could serve as a benchmark for many future research. And we believe maximizing the use of AI in this sector could strengthen Malaysia's food security, which then would lead to sustainable aquaculture development. And that's all for my presentation. Thank you so much.
Thank you. We really appreciate your project. And I will ask to participants if they have some questions or just some comment, suggestion. And if they wish, they can also, write these ones in the chat. Thank you.
Anyone has questions? Okay, I have one. You are identified, a fish disease. How many varieties of fishes have you? Can you hear me?
Sorry, can you repeat the question?
There is some glitches, Doctor. Yeah.
How many varieties of questions?
Sorry, Doctor, how many?
How many varieties or how many types of fishes?
Yeah.
Oh, two types of fish, sea bass and sea bass. One type of fish, sea bass.
Okay, so you went with
And
only one.
How many samples, Arlene, you want to share? How many samples have you tested?
In this research, we use 60 images, but in the training process, we use more than 1,000 images for now.
Okay. So 1,000 images, how many iterations have you done?
Sorry,
how many iterations, repeats? So how did you reduce the error?
Sorry,
okay, now mind. It's a learning. Try to have more iterations, reduce more errors, so that you get better results.
Yeah.
Okay. Right. Thank you. We'll go to the next person.
Okay, we can move forward with the next presentation. Next topic is on the prediction of water quality using machine learning techniques. The guiding experts are Associate Professor Dr. Hazlyna Harun, Dr. Juhaida Abu Bakar. The student is Syaqinah Safaruddin. Thank you. If you are willing to share your presentation with us, it will be okay, great. Thank you.
Hi, everyone. I am Dr. Hazlyna, supervisor. My student was Shashi Safaruddin. Can everyone hear my voice?
Yes, ma'am.
Yes,
Go
yes,
ahead.
correct.
Okay. Actually, this project, prediction water quality by using machine learning, utilize the real data that we obtained from the Semborong River that located in southern Malaysia by using actually various related sensors. We collaborate with two other universities, which are UTHN and UPSI. Furthermore, actually this project will make prediction on whether the river is polluted or not, based on machine learning. This actually this project is sponsored by also sponsored by the Ministry of Higher Education Malaysia. Okay, for the further explanation will deliver further explanation from my student Syaqinah. Thank you.
Okay. Can everyone hear my voice?
Yes, you can go on.
Okay. Good afternoon, everyone. Thank you for allowing me to share my research study today. So I'm Shaqi'nah, and I'm excited to share with you guys about how the machine learning can help predict and ensure a better water quality. So before we begin, let's on an overview of my research. So basically, as we know, water is a precious resource and its quality directly impacts on our health and the environment, of course. So the accurate prediction of a water quality can help us and detect the potential contaminants. It can make informed decisions, and also it enables us to safeguard public health, to protect the ecosystems, and also the sustainability of our water resources. However, monitoring water quality is a complex task. Traditional method involve a manual sampling, and it could be time consuming and also quite expensive when it comes to the process. So moreover, water quality is influenced by various factors, including including the weather conditions, pollutant sources, and also the human activities. So analyzing the such vast and dynamic techniques, dynamic data sets, it requires advanced techniques that can handle the complexity and provide accurate predictions. So this is where machine learning comes into play, and machine learning algorithm can process a large volume of data set. It can identify patterns. Also, it can make a decision based on historical records and real-time monitoring. So by leveraging the machine learning, we can develop models that learn from data and provide accurate forecasts of water quality parameters, such as the pH of water, the temperature of water, it could be a dissolved oxygen, and so on. So basically, we are focused on rivers. Why? Because rivers is a primary source of fresh water for various purposes, including the drinking, agriculture, and of course for industrial activities. So ensuring a good water quality in rivers is essential to meet the water needs of human population, for support healthy ecosystems, and also for sustain economic activities. So for the areas, we use the outlier detection under AI sub area, which is under pattern recognition, and also the several supervised learning algorithm under machine learning. So basically, this is what the framework that involve a machine learning looks like, where it started with the data acquisition process. The primary, so basically the primary data were collected from one of the rivers in Malaysia, and it was collected from July 2021 until February 2022. Includes about more than 30,000 samples. Then we go through the parameter selection process, where we select the parameter that could give important information at the end of the results. So this is the listed parameter that we choose based on their information. And then after that, we go through the data preprocessing, where we use the outlier detection technique to clean the data, the water quality data, because we believe that the more the data is clean from noise or any outliers, the more the result will be accurate at the end of the results. Then the next process is where we apply the machine learning techniques. So first, the data are divided into data training and data validation using the ratio of 70 and 30%, where the data training is 70% of the total of the data, and the data validation, where we use as a unseen data, contain 30% of the total from the data. After that, we compare several machine learning techniques, including support vector machine, random forest, multi-layer perceptron, and k-nearer neighbors. We use the default values for each of these parameters to do the process in where we apply the machine learning. Okay, after that, we compare each of the machine learning algorithm using the performance evaluation, which one have a better performance. So based on the results and based on the result that we have here is we can conclude that we need no more manual methods, which is we have manually bringing the water sample to a laboratory to do some experiments and wait for 2 or 3 days, even be 1 or 2 weeks to have one result. Either the water or river is polluted or unpolluted. So by using machine learning, it proved that we can save a lot of time and cost, especially where the results show that random forests here have a better performance rather than the 3 algorithms, and shows that this machine learning algorithm can give a better result in predict whether what kind of status of the river. So this study's findings have the potential to aid in preventing water environmental disasters, beside for the decision makers for the proper planning and management of the aquaculture industry. And we believe that this is what we can call a digital solution for a well-being of society. That's all from me. Thank you.
Okay.
Thank you. Thank you. We really appreciate your presentation. I would ask to each member of this team if anyone has some questions, comments. We are here. Also, if you wish, you can write them in the chat we have.
I have one question. When you take up a quality of water, are you taking the parameter called total dissolved, solids? There's a parameter called total dissolved solids because.
Apologize, Doctor. I beg your pardon, the questions.
I know. What are the parameters you have taken in quality of water? Determines quality of water, right from pH to various variables, suspended solids. How much of impurities can it have? How much of dissolved solids it can have? What is that? What do you mean by quality of water?
Yeah, I think what Dr. Krishna meant is what are the parameters, what are the factors that we have considered? Perhaps Dr. Krishna, from your side, there are some glitches on the audio, so we could not really hear the voice.
Oh, understand.
No, it's okay.
What are the qualities you have? That is enough.
Yes, yes. Is on the parameter.
So what kind of parameter that have been used to predict the water? Okay, basically there's 6 parameter involved. The first is pH, dissolved oxygen, electrical conductivity, oxidation reduction potential, and the last one is water temperature.
Oh, temperature. Right. Good. Each of this has to be evaluated on a varied measure and permitted levels, because water in one place of the world will not be of the same quality across the world. So it will vary from location to location, and it is consumer specific. So that is the reason I asked you about the quality parameters what you're evaluating. Good effort, and try to get more models involved. Right.
Okay, thank you, Doctor. Thank you.
Very good effort and wonderful presentation. My congratulations. Okay, so now I think we can move forward and leave the floor to another group. That is the one guided by Professor Sharvari Tamane. So the topic is on the attendance management system by opencv. The students are Vinay Sukase, Anish Dadegaonkar, Anuja Rajhans, Shripad Shevlikar. Sorry if I'm not able to pronounce very well the name and the star names.
That's okay, ma'am. Thank you so much.
Thank you too.
So, yeah. Anish, are you there? And your all the team members?
Yes, ma'am. We are right here.
Yeah. So I'll just introduce the topic and then you can take over the charge.
Yes,
right? Yeah. So good afternoon, everyone. I would like to thank the organizers for giving us the opportunity to introduce a groundbreaking project that aims to revolutionize the way we take attendance. My students will be presenting the project work on the topic automated attendance system using face recognition powered by opencv. Traditionally, attendance taking has been a laborious and time-consuming task, whether it's in educational institutions or corporate offices or any other organization. The process of manually calling out names or roll numbers or using sign-in sheets has been often been prone to errors and inefficiencies, but fret no more, as our project offers a solution that will simplify this process and bring it into the digital age. The automated attendance system leverages the power of face recognition technology to streamline the attendance process. The system utilizes a camera which captures image of the class, and then this image is then processed by a sophisticated software program that recognizes and matches the faces with their respective identities. The backbone of this system is opencv, a popular open source computer vision library. opencv provides a range of tools and algorithms that enable accurate and reliable face detection recognition, and matching. So by employing this powerful technology, our project ensures that the attendance records are both precise and efficient. So the benefit of the system is it eliminates the need for manual intervention, reducing the chances of human errors and time wastage. Moreover, the data collected by the system can be easily integrated into existing databases or attendance management systems. And this enables the administrators and educators to access real-time attendance information, generate reports, and analyze attendance patterns with ease. So this system is actually using the CNN, convolutional neural networks, and the HOGs, that is histogram of oriented gradients. So this technique is using this to localize the portion of an image and enables the system to capture important details to contribute to accurate face recognition. So by analyzing these gradients, the system can capture and represent crucial details such as the ages or the texture variation on the person's face. So which will be helpful for detecting the different faces at the time of the capturing of the image. So in conclusion, the system is using the opencv, CNN, and the histogram of oriented gradients technique, and it represents a cutting-edge solution for attendance management with enhanced accuracy, security, and reliability. So I invite my students to present their work. Yes, Anish, you can go ahead.
Hello, ma'am. Good evening. May I audible?
Yeah, you are audible.
Attendance maintenance is a significant function in all the institutions to watch the performance of the student. Every institute does this in its own way. Some of this institute use the old paper or file-based system, and some have adopted the strategies of automatic attendance using some biometric techniques. This project will be helpful for the new upgrades in attendance or the management systems. Let's begin further.
Okay, so the objectives of the project are it will automate the process of taking attendance. It will eliminate the need for manual data entry and reduce errors. Using face recognition, we will prevent body punching. It would reduce the effect of body punching, where it will provide security and privacy, and also provide the real-time monitoring to the system. It will also provide teachers to identify and address the issues of the concern for students for maintaining the attendance management system. Now let's have the look at need of our project. So the first use is it would be efficient, it would be secure, it would be accurate, and real-time monitoring. Efficiency would be like face recognition technology can automate the process of taking attendance. It would eliminate the need for manual data entry and reduce the errors. This can save time for teachers, administrators, or HR personnel, allowing them to focus on other important tasks. We are talking about security. The face recognition systems can be more secure than traditional methods of taking attendance, such as using paper sign-in sheet or relying on a student's memory of their own attendance. Accuracy. A face recognition system can accurately identify and track individuals, like likelihood of errors that can occur with manual data entry. This can help them to ensure the attendance records that are accurate and reliable, which can be important for reporting purposes or for naming students who may miss the class. Real-time monitoring can be said as it would be like a face recognition system can provide real-time monitoring of attendance, which would allow teachers or administrators to quickly identify and address attendance issues. This can be especially important in larger institutions or workplaces where it is difficult to keep track of individual attendance manually.
Okay, so our spotlights will be in the project. We are adding some futuristic kind of features, which are user-friendly interface, also analysis report generation data, storage at a single space, also multiple logins will be provided, also shareable outputs into many forms, which should be as PDF, Word, Excel, etc. will be provided, also many more. So let's begin with why we need a proposed or a new system where we are having the existing system. So in existing system, manual entry for the students, handwritten registered entries, more human efforts, and single face detection using camera. Whereas in the proposed system, aims to reduce the paperwork, save time to generate an accurate result, to provide best user interface, and it is highly reliable and approximate result from the user.
Now switching over the GUI part, as we see the software we are using will consist of the different login panels, like there will be an admin panel, teachers panel, and student panel, which will be they are using to log in our software. The screen you are seeing is the GUI representation of the login category. First, the admin will use the admin ID, username, or the password to log in the software, and they would have to do certain activities which have to register the staff, students. And after seeing in the next activity session, here are the generating report system. After that, we are using a HTML CSS form, which will be used to register the students in our, this is actually a bootstrap system, bootstrap template, which we are using. And then the admin will do the prerequisite works, which have to compulsory add the teachers. Teachers will attend the session, and then the students who are attending the session will automatically generate the attendance according to the teacher's need. And the overall output will be provided in an Excel sheet or a PDF format according to the user need. Then coming over the teacher activities, these are the teacher activities. For example, on the left side, you are seeing there are some tabs which shows the sessions. For example, we are handling some classes for maths, physics, chemistry. They will be shortlisted on the left side according to the sections and batches. And on the right hand side, there are the list of students who will be attending the class. Then after that, this was a front end part, and coming to the back end part, we will be designing a database system. In the database system, this is an entity relationship model diagram, which shows the student details, attendance details, staff details, timetable, and user, which have the certain entities which will be used in the backend process.
Okay, so as of now, we are in more early development phase of our project. So we have first studied some research papers, and after that we have we are deciding to which implement which algorithms. So in the first research paper, we studied that they are using the Har cascade algorithm, and they use face ID in order to detect the faces. In the next one, they use the LBPH, which is the linear binary pattern histogram. They have the benefit of this algorithm is it is very easy to implement, and it has very less noise interference. And we also studied other research papers. So based on this, the best way to do this would be using faster RCNN and using Cetaface engine in order to detect faces in faster RCNN. First of all, it has potential of detecting object regions, and then like it actually group them based on similarity in the colors, the textures. After that, it is good at feature extraction. CNN we are using CNN to extract a fixed length vector feature from any region. The third is the object detection, which is the face of the student. So here we are, as I said, in a very early stage. So we have just started the coding part of this.
According to this code, this is a snippet of a example code we were using by using the model CNN, which shows that after using this code, we are encoding and performing some operations on a particular image. Using on the right side, the image is displayed. Where the image will be detected, our webcam will be activated, and the we are recognizing the face only part and enlisted it by the green color border system, which is used by the CNN model.
Thank you, everyone. We would like to answer if you have some questions.
Okay. Dr. Fabian. Okay, I'll go with the question. I have one question on opencv. In the last slide, you showed facial recognition of one orientation. What orientations did you take to train your system?
Sorry, sir.
So can you repeat?
How many orientations have you taken to train one person?
So actually in a code, it's moving in a loop system where it will capture the number of faces, the loop we are decided. For example, we are deciding 3 faces till now. It will capture and regenerate the 3-face system.
No.
The code.
My question is, see, you see my face in the video, it's straight, the front view. Yes. Are you taking my side view, left side view, right side view, movement of my head down, movement of my head up, like this? How many orientations have you taken for each person?
So we will train almost 6 variations, like top, down, left and right side, while registering in the database. So it can compare and manipulate the photo.
And we are also considering the distance.
Distance is more important. How much is the distance which you have tested?
We have till now it's not so far distance, sir. It's using by only webcam till now, and furthermore we are planning to do in a camera system, in a classroom camera system.
Okay. This has a lot of plenty of opportunity to get implemented quickly. There are many competitors also. So identify your competitors and work on what they don't give. So it will be easy for you to commercialize.
Yes, sir.
Okay. Best wishes. Bye.
Thank you, sir.
Thank you so much, sir.
Thank you so much, sir.
Thank you. There are other questions, comments? No, so we can leave the floor to the last group, the last team, that is guided by Professor Dr. Sujata Kedar. The topic is Gator Minutes of Meeting Generator. The students are Nihar Hemant Kumar Kenny, Nair Ajay Ravindran, N Guru Akaash, and the last one is Shubham Zope. So please share your presentation with us so you can present. Thank you.
Yes, ma'am. I'm audible, right? I'll quickly share my screen.
Okay.
Yeah. So is the screen visible?
Yes, okay. Yes, we can see the presentation, yes.
Okay. So hello, everyone. We are here to present our application named Gator, based on the domain of artificial intelligence. Our project mentor is Dr. Sujata Kedar. I am Nihar Kenny, and my team members are Guru Akaash, Shubham Zope, and Ajay Nair. Now, these are some of the contents that we'll be covering in this presentation. Moving on to the introduction of our project. Now, in the recent years, particularly with the rise of remote work scenarios, numerous organizations have adopted virtual platforms such as Microsoft Teams and Google Meet for conducting their official meetings. However, despite the advancements in virtual communication, participants are still required to manually document the minutes of these meetings. Our objective with this application is to streamline and automate the laborious process of manually drafting the minutes of meeting. Moving on to the problem statement.
So in the modern scenario, the work from home is on the peak, and most of the meetings are conducted online using Microsoft Teams, Google Meet, and Zoom, which provide a feature to download the transcript, but it does not provide a feature to summarize the meeting. So here are the 3 dimensions of the project. The first one is to parse the transcript to figure out the attendees and duration of the meeting. The second is we have to take the transcript of the meeting and generate the summary of the meeting along with the action items. That is the important lists of the meeting. The third dimension is when there are no transcript available for the meeting, then we have to do speech to text conversion to obtain the transcript for the model. Moving on to the next slide. So here comes our solution, Gator, which is an end-to-end minutes of meeting generator app. It is a tab-based Microsoft Teams app which provides three essential features, that is the summary, action items list, and other meeting-related items like the date, time, and other link of the meeting and all. These are created using MS Graph API calls, which auto-extracts the attendance reports and meeting transcripts. This GistGator model uses a BART model in its backend, which is bidirectional autoregressive transformers. This model is fine-tuned on 5 different data sets, that is AMI meeting corpus, XSUM, SAMSUM, dialog sum, and custom consolidated data set, which is created by us from scratch. Parameter tweaking is also done to optimize the model's performance efficiency. Moving on to the next slide.
Now going on to the demonstration. This is our GistGator application, which has been itself integrated in the Microsoft Teams. In the sidebar, you can see the Microsoft Teams icons, and our GistGator icon is also located there itself. Now, if you see on the main screen, there are two options. First, sign in with Microsoft and other upload files manually. First, we will go ahead with sign in with Microsoft. Once the user clicks on its button, the user will be asked their credentials, the email and the password, which will log the user in. And after that, the meetings which were organized by this user will be displayed here. Now, if we click on any of the meeting, the transcript and the attendance report will automatically be fetched from our system and displayed here. Now, the attendance report you can see has been displayed in a JSON format, which you can click on upload button and convert it into an readable format. Here you can see the participants, the meeting start time, end time, the attendees. And also now coming on to the transcript, you can click on upload transcript button and convert it into an readable format, which you can see it has been displayed in a dialog format now. Now after that, user has to click on summarize and get action list button, which will generate a summary and the action list of this transcript. Now we have used Teams Toolkit, which is a platform given to us by Microsoft for developing these applications in the Microsoft Teams. We created a Microsoft 365 tenant for using this Teams Toolkit, and also after that use Microsoft Graph APIs, which helped us to automatically fetch transcript and the attendance report from the system. After that, this transcript and action list has been given as an input to the model, which has been trained on our SAMSUM, XSUM, DialogSum, and our own consolidated data set, which we have created on our own. Yes. And now the result will come here in a very short minutes. Yeah, so now you can see that the summary and the action list are being displayed. Now, if the summary or action list has some grammatical mistakes, so we have integrated a Grammarly extension through which the user can correct those mistakes here itself. And after that, once the mistakes are being corrected, if there are any, the user has to click on show results button. Here he can see all the content which was displayed previously, the attendance report, a summary, and the action list. Now the user has two options. The user can either download the minutes of meeting or he can mail. If you click on download, a TXT file will be downloaded, which will contain all the details like attendance report, minutes of meeting, and the action list. And if the user clicks on mail minutes of meeting, all the content will be automatically fetched from our system and will be displayed in the body of the mail. The user will just have to enter the recipient's email ID and click on send button. Now coming on to our second option, which was upload files manually. The user has to select first an Excel or CSV file for the attendance report. Yeah. So now user has to click on upload attendance report button to convert it into an readable format. Now after that, the user has uploaded transcript. Now if the user has an audio or video, then the user can use our STT speech text to generator app, which the user can download by clicking on this button. So this is our speech to text generator application. In this, the user has to click on browse button and select the video or audio and click on convert STT button. So a transcript will be generated, which the user can later download and upload it here. The user here has to again click on the upload transcript button to convert it into a more readable format, and then click on summarize and get action list button, which will follow the same process as we discussed earlier in option 1. Now going on to our Google Meet extension.
Hello, am I audible?
Yes.
Okay. So this is another version of our application which runs in Google Chrome. So we have created a GistGator extension, as you can see, which forces us to switch on our caption so that it can extract the transcript from that. So once the meeting is over, the user can click on open GistGator button in the extension. Which will open up a web page besides the meet, which will extract the meet link, the date of the meet, and the speakers in the meet, and it will also extract the transcript. The transcript is basically extracted by extracting the captions that were generated in the meeting and then storing it in Google Chrome storage. And after that, it extracts the whole transcript in one go. And after that, it's the same process. The user can click on the summarize button and the transcript will be sent to the both a summarization and action list generation models, which will generate both the summary and the action list, which the user can either download it as a text file or he can send it via mail to his employees. So now let's see the statistics. So some statistics, we had run our model through long videos. Like I would just glance through the first row. We took Nirmala Sitharaman, our Indian financial minister's latest budget video, which had a length of about 86 minutes and had about 8,124 words in the transcript. So we ran it through our model and we could generate a summary of about 401 words. And the time taken for the summary generation was 7.2 minutes. The time taken for the action list item list was 7.5 minutes. And the overall time taken was 7.5 minutes. You might be confused a bit here, but the reason why we got just 7.5 minutes is that we were doing parallel processing here using multi-threading. So both the summary generation and the action list generation tasks were carried out simultaneously. And in the second table, as we can see, the text compression rate of the video was 95.1% of the transcript length, and the processing time was about 8.7% of the video length. Now I'd like to conclude our presentation. So 3 main unique selling points of our application are: we have integrated our application into Microsoft Teams, which is a tab-based application. And we have also custom trained and fine-tuned our BART model for the summarization and action list generation tasks. We have a multi-platform conferencing app, which works on Microsoft Teams and Google Meet, as well as offline. We have also done parameter tweaking to improve our model's accuracy. And we have created our own custom consolidated data sets. I would just like to explain one way of how we created our data set. As we all know that ChatGPT is the new trend now. So we have created summaries, conversations, and transcripts from ChatGPT, about 5,000 or something. And from that, we have passed those text files, and we have created our data set so that we can train our models on it. And we also have a desktop application which the companies can use for offline meetings, which have automatic speech to text generation. Thank you. Any questions? We would love to answer them now.
Thank you. Thank you a lot. So there are any question, comment, suggestion? This is the last presentation. So if you wish to also, if you have some general comments also for the other presentation, maybe it will be a great occasion to share with us your impression. Anyone?
Hi, hello. Maybe just one question from me.
Sure.
Thank you for sharing the wonderful project to the team. I just wonder, is the BART model, B-A-R-T, BART model, is a language model, or what kind of model is that?
So the BART model is a language model. It
Okay.
consists of BERT as well as GPT. It uses BERT's encoder and GPT's decoder, but not the later versions, the earlier version, GPT-2's decoder.
Okay,
So
I see.
it is completely similar to that of a Transformers, the original Transformers that was released after LSTM. So it is completely analogous to that of Transformers.
Thank you.
I have one more question. You were saying that it goes with multi-platform. What other platforms have you tested?
So currently, sir, we have created an application for Microsoft Teams, which runs in Teams itself. For Chrome, that is Google Meet, that runs in Chrome and Chromium supported browsers, and it is for Google Meet. These are two online conferencing platforms that we have covered, and also we have a local application.
This meeting is being recorded.
For locally running the offline meetings. That is a video recording can be sent used as input for that application.
Okay, nice. Thank you. Dr. Fabiana?
Yes, okay. So in the chat, okay, there are no other questions, just one for Noor, but Noor has already replied to Erwin Harris, so we can just conclude this webinar. Thank you all of you for these wonderful projects. The presentation are very impressive, the projects are very interesting. So I suppose, Krishnan, we can conclude here our webinar, and thank you all of them to be here with us to share this wonderful project.
Okay. Thank you. Thank you very much. Thank you very much, Dr. Fabiana, Dr. Nooraini, Dr. Tamane, Dr. Priya, and all participants who presented their projects. Okay. Thank you very much. We share your certificates and.
Thank you so much. Thank you.
Doctor, can we have one photo?
Okay.
For the event.
Thank you. Bye. Bye.
Dr. Nooraini, you had some questions.
I just want to snapshot the screen. Okay, thank you, everyone.
Thank you all. Thank you all. Bye.
Thank you.